Hello, my name's Al Boudreau. I'd like to welcome you again for the series called Wonders of Astronomy. This is our fourth in this series, and we're celebrating the International Year of Astronomy 2009. The theme of this worldwide event is The Universe Yours to Discover, and we'd like to invite you to attend a star party, a planetarium event, or some other event to commemorate this year and just try to look through a telescope this year and see the wonders of astronomy. Now, in this program, what we're going to try to do is cover the entire solar system, starting here at Mercury, going way out to Pluto itself. We're going to briefly cover each planet and its significance and its place in the solar system. Now, this is a slide that shows the planets to scale. It's obviously the distances are not to scale, but at least the sizes of the planets. We can see the sun here being quite large, can't even fit in the picture. Then we have the four small rocky planets, with Earth being the third rock from the sun. Early on in the creation of our solar system, there were probably 100 different little planetoids in this area, and this is the result. We've finally come down to four rocky planets. In between Mars and Jupiter, there's an asteroid belt, and then we have Jupiter, the large giant planet. Saturn after that, Uranus and Neptune, and finally Pluto, way out here in the Kuiper Belt. The Sun itself has 99.8% of the mass of the entire solar system in it, and Jupiter and Saturn have 91 of the remainder. So we are just crumbs on the table. We're very small in comparison. Now, let's start with Mercury. It's hot. It's close to the sun and very hot. The temperatures typically are minus 290 on the cold side, all the way up to 800 degrees Fahrenheit on the hot side. It's 35.9 million miles from the sun, so it's fairly close compared to us. It has no moons. It just sits there by itself in its small elliptical orbit. It's a small planet by comparison to the others, 3,025 miles. Here's a comparison down here. Mercury versus our moon versus Jupiter's moon Ganymede. You can see that Ganymede is actually larger than Mercury, and also Saturn's moon Titan is also larger than Mercury. Now, it has a highly elliptical orbit, a lot more elliptical than the other planets, and it zips around in this orbit at 107,000 miles per hour. It takes Mercury only 88 Earth days to complete that circuit. It rotates on its axis in only about 58 hours. And it has what we call a resonance. And then it makes 3 rotations for every 2 orbits of the sun. It's rather odd, but many planets get into these type of resonances. It's interesting that one day on Mercury is longer than a year. Why is that? We say we only 58 Earth days here to complete a rotation. Well, if this was a spot right here and it began to rotate around, by the time 58 days came around, it would be in this position. So it would then be looking out this way. So it needs to continue to rotate around until it finally can look back at the sun when it's over in this position here. So that's why a day is actually longer than a year on Mercury. Now, Mercury's surface really looks a lot like the moon. It has a very weak magnetic field. It's only 1% of the Earth's magnetic field. That means it doesn't get a lot of protection from the solar winds. The solar winds come in and strip the atmosphere away from Mercury. So essentially it has no atmosphere. And all we have left then is a very cratered surface, which looks remarkably like the moon. Now, the next planet out is Venus. Venus is shrouded in thick clouds, so if we look at it just in visible wavelengths, we can't see anything but the clouds. However, we can use satellites that use cloud penetrating radar to get an idea of what the surface looks like. It's just about Earth size. It has a diameter of 7,521 miles compared to Earth's 7,920 miles. So it's just about the same size. It has a very dense atmosphere, which is 96% carbon dioxide. Plus it has about 3.5% nitrogen. Because of this high degree of carbon dioxide and the thickness of the atmosphere, it has a runaway greenhouse effect. We talk a lot these days about global warming and greenhouse effects on the Earth. Venus has it big time. The surface temperature is pretty uniform throughout the planet, and it's usually about 872 degrees Fahrenheit. It would make a very good pizza oven. The atmosphere pressure is 90 times that of Earth, and that's extremely dense. The winds can go up to 190 miles an hour, 300 kilometers per hour. Goes around the sun at 75,600 miles per hour. You'll notice as we go out in the solar system, these speeds will decrease considerably to where we get out to Pluto. It will be going very slow compared to the inner planets. So the further away we go from the sun, the slower the speed in orbit. So this one is 75,000 miles an hour. It has an inclination in its orbit of only 3.4 degrees. And you recall that, as you see with Earth, we have 23.5 degrees. So this is very small inclination, so it has very minor seasons. Because of the cloud cover, the temperature stays pretty uniform anyway on Venus. On Venus, we're 67.1 million miles from the Sun. That's about 0.72 the distance between the Sun and Earth. Again, its axial rotation is 273 Earth days. So you can see that is actually longer than the year on Venus. And it has retrograde motion. That's one thing that's very odd about Venus. All the other planets rotate in a counterclockwise direction. This one rotates in a clockwise direction. And we're not sure exactly why that is. Now, the Russians have actually landed probes on Venus, and the Russian Venera spacecraft, there were actually 16 of them total, and 12 of them actually made successful landings on the planet, and these are pictures from the probes before they melted. Because of the high temperatures, the probes didn't last very long at all, just a few minutes, but it was long enough to at least get some pictures and radio those back to Earth. So we have used computers now, along with the radar images that we've gotten from our spacecraft, to reconstruct what it might look like if we were actually standing on the surface of Venus. It's very few craters, meaning it's a very young surface, and it's just predominated by volcanic activity. Now let's visit that third rock from the Sun, our favorite planet, Earth. We are now 93 million miles from the Sun, and astronomers define that as 1 astronomical unit, and we'll be using this number quite a bit in the subsequent slides. So an astronomical unit is simply that average distance between the Earth and the Sun. Now, here on Earth we have a very strong magnetic field. Because of that, we're protected from the solar radiation that comes in. As I said before, the diameter is 7,920 miles, fairly decent sized planet. Our atmosphere is 78% nitrogen, 21% oxygen, 0.93% argon, and just a tad of carbon dioxide. You know, in global warming, we're worried about that carbon dioxide level. It's pretty small by percentage, but it has a dramatic effect on the amount of heat that the planet absorbs. 71% of our surface is covered by water. Now, we are zipping around in our orbit at 68,400 miles an hour. And because our axis is inclined 23.5 degrees, we get the seasons. When the northern hemisphere is tilted towards the sun, we have summer. In fall and in springtime, we're perpendicular to the sun's rays, and then in winter, we're facing away from the sun. So this inclination of our axis is what creates these seasons. And as you know, one Earth year is 365.25 days. Now, the Earth has a moon, and a fairly large moon by comparison to most of the other planets. Our moon is 2,160 miles in diameter, and it's located 240,000 miles from the Earth, and it orbits the Earth every 27.3 days. Now, we also have this nice atmosphere that we live in. We live here in the bottom part. Even our airliners are down here in the troposphere. We have the stratosphere above that. And finally, we continue up, up, up. And there's really no exact point at which the atmosphere quits. It just gets less and less dense. In fact, the International Space Station, way up at 240 miles above the Earth's surface, still needs to be reboosted occasionally due to the drag of the atmosphere, even though it's very thin, just a few molecules. That's enough to slow it down. Now let's jump from Earth to Mars, the last of the rocky planets. Here's a comparison of Earth with Mars. You can see that Mars now is about half the size. Has a diameter of 4217. It has an atmosphere also, but its atmosphere is quite different than Earth's. It's 95.3% carbon dioxide and only 2.7% nitrogen. That high degree of carbon dioxide, you'd think there would be a tremendous greenhouse effect, but the atmosphere is only 1% that of Earth's. So it's very, very thin. In fact, if we walked on the surface, we would need pressure suits because the pressure is so low. And the temperatures range from -200 degrees to +70 degrees Fahrenheit, although the average temperature is usually below freezing of water. So most of the water that's on Mars is trapped in terms of ice underneath the surface. Mars now zips around in its orbit at 54,000 miles an hour. Again, you see these numbers going down as we go further out. One Mars year is 687 Earth days, or 1.88 years, Earth years. Now, its axis is also inclined and pretty close to us. Remember, we were 23.5. Mars has an axis inclination of 23.9 degrees. So it also has seasons, summer, fall, winter, and spring. But because the years are so long, Mars' seasons are almost twice what they are in length on Earth. It has an axial rotation very similar to Earth's, 24 hours, 39 minutes. So if we sent astronauts to Mars, they would get accustomed very easily to the daily sequence on Mars. And Mars has two moons, two very small moons that are probably just captured asteroids. Now, this orbit of Mars averages 142 million miles from the Sun. So we're getting out, it's 1.5 times the distance of the Earth from the Sun. Now here's a picture of those two moons, those rocky little asteroids that were probably captured at one time. We have Deimos here with a diameter of only 7.8 miles, and Phobos is 13.8 miles. So very small. And like I said, obviously there were asteroids captured at one time. The terrain of Mars is a lot like Earth's in many ways. We have deserts and mountains. We have volcanoes. We have craters, a lot more craters than we have on the Earth. Not as many as we have on the Moon, but we have quite a large number of craters. And one interesting feature of Mars is this tremendous valley called Mariner Valley that goes from here all the way over to here. It's 3,000 kilometers long. If we put this on top of the United States, it would reach from Los Angeles to New York City. Now, we've had many spacecraft visit Mars, and currently we have 2 rovers that are still operating after 5 years. They were originally planned to operate only for 90 days, and they're still going after 5 years, although Spirit is having a little trouble these days. Opportunity is still going strong. These have allowed us to actually get up close and personal with the surface of Mars, and here we can actually see what the surface of Mars looks like. That red color is from iron oxide or rust, which predominates the surface. Now let's jump up to that large planet, Jupiter. It's just on the other side of the asteroid belt from Mars. You can see here that it's now 5.2 times the distance of the Earth from the Sun. And it's in this range of planets that we call the gas giants: Jupiter, Saturn, Uranus, and Neptune. It is the protector of the inner planets. These larger planets tend to capture any loose asteroids or comets that might be coming to the inner solar system. So it's somewhat of a protector for us. Now it is the largest planet, as I said, at 88,700 miles in diameter. That's 11 times that of the Earth's. It has a very thick atmosphere, 90% hydrogen, 10% helium. And it has no surface. This gas just gets denser and denser and denser as you go in. There's no surface on which we could land or stand on if we went there. The gravity is 2.5 times that of Earth. Even though it's quite large compared to Earth, you can see here the comparison of Earth and Jupiter. It's quite large, but because it's not too dense, because it's mostly hydrogen, the gravity is only 2.5 times that of Earth. Now we amateurs can actually observe with our telescopes in a lot of detail the surface features of Jupiter, including we can actually see these shadows that cross the face of the planet every now and then due to one of the large moons crossing in front of it. Now Jupiter is going around the Sun at 29,000 miles an hour. Remember back there when we looked at Mercury, it was 107,000 miles an hour. Now 5 times the distance from the Earth, we're down to 29,000 miles an hour. And one Jupiter year is almost 12 Earth years. But the rotation a day on Jupiter is very fast. It's only about 9 or 10 Earth hours, and actually 9 hours and 50 minutes. Because of that fast rotation with such a massive planet, it's actually flattened or squashed 10%. So the equator is 10% wider than pole to pole. If we went there with a typical spacecraft, it would take us 8 years to get there. So it's quite far out compared to our inner planets. Now, Jupiter has some interesting surface features. One is this giant red spot, which is a tremendous storm. And that storm has been visible ever since we've been looking at Jupiter through telescopes. So for over 300 years, it's been visible to us. So we don't know how long it's going to last. It's been there ever since we can see Jupiter in detail. Jupiter has 63 known moons, but the largest ones that we can see easily, even with a small telescope, are called the Galilean moons. They're Io, Europa, Ganymede, and Callisto. And as I said before, Ganymede is pretty large for a moon. It's actually larger than Mercury or Pluto. Now, that atmosphere, the thick atmosphere of Jupiter is very dynamic. We see all these swirls going on here. These go continually changing and swirling. We see the giant red spot again. We see some other storms here. And some are red and some are white. But there are many storms, and the winds can get up to 400 miles an hour, so it's a pretty dynamic place. Now let's jump out to Saturn. This is a planet that we all love because of the color of the rings. Oh, okay. We can see here Saturn is now 9.5 times the distance of the Earth to the Sun. It's out here among the gas giants again. Being the second largest planet, it has a diameter of 37,400 miles. But those rings extended out to almost 250,000 miles. It has a very low gravity because, again, like Jupiter, it's mostly hydrogen, so the gravity is only 9/10 that of Earth's, and it's would actually float. If we had an ocean big enough and put Saturn in it, it would actually float. So it's not very dense at all. We amateurs actually can get a very good view of, this is a picture taken with an amateur telescope. You can see it's got a pretty good detail compared to this one taken with a space probe. Now, Saturn now in its orbit is going around the Sun at only 21,600 miles an hour. It does have an inclination of 26.7 degrees, so it also has seasons, summer, fall, winter, spring, but they are quite long because one Saturn year is almost 30 Earth years. It also has a high spin rate, 10 hours and 12 minutes, so it, just like Jupiter, also is flattened a bit. And the distance, again, from the Sun is 887 million miles. Saturn has an interesting planetoid moon called Titan. Titan has a nice thick atmosphere. The atmosphere on Titan is nitrogen 90%, which is similar to Earth's in a way. It has argon, and it has a high degree of methane, 3% methane. That means it rains on Titan, but when it rains liquid methane. So we actually can see these channels, these rivers. We can see here coastlines where at one time these were lakes of liquid methane. Now, luckily it doesn't have oxygen on it, because if you lit a match there, the whole planet would go up in flames. We actually, the Europeans did land the Huygens probe on the surface of Titan, and this is an actual picture of the surface, which shows a very flat surface with large rocks which are actually made of ice water. Now, let's go way out there. Let's go out into the cold and look at Uranus, Neptune, and Pluto. And Pluto, as you see, is in what we call the Kuiper Belt. Now, here we are, way out here in this area, Uranus, Neptune, and the Kuiper Belt. The Kuiper Belt is a large collection of junk, essentially, that was left over from the formation of our solar system. The large planets formed very nicely, the eight major planets, and then what was left here was a bunch of small planetoids and comets and things of that sort. It's pretty far away from us. When our New Horizons probe finally reaches Pluto in 2015, the signals from that spacecraft will take 4 hours or more to reach Earth. That's how far away it is. And those radio signals travel at the speed of light, 186,000 miles per second. Yet still it's going to take 4 hours. So this is a pretty big place we live in. The Kuiper Belt essentially extends from about 30 times the Earth's distance all the way out to maybe 100 or so. Uranus is quite interesting. It's the third largest of the planets. It has its axis, for some reason, tilted 97 degrees. Remember, our axis is tilted only 23 degrees, 23 and a half degrees to be exact. But this one somehow is actually laying almost on its side as it goes around the sun. It's quite interesting. It's fairly large. It would take 4 Earths to go across Uranus. It has a diameter of 31,690 miles. This is the first planet that was discovered by a telescope rather than by eye. William Herschel in 1781 actually discovered this planet. Made him quite famous. Now, as I said, because of a tilt like that, it will have seasons, but during the summer, the northern hemisphere is pointed almost directly at the sun. In the fall, we have what we might call normal days, in which about half and half. But here in the winter, the northern hemisphere is pointed away from the sun, and it's extremely cold, where the southern hemisphere is pointed directly at the sun. So it's quite an interesting planet. It's now 1.8 billion miles. We're not talking in billions of miles, not millions. Billions of miles from the sun, or 19.2 times the distance of the Earth from the sun. It has an axial rotation of only 17.9 hours. And again, it goes in the normal counterclockwise manner. And it has 55 known moons. The next planet is the gas giant Neptune. It now has about the same diameter. It's a little bit smaller. It's 3.88 times the Earth's diameter. The temperature at the cloud tops is minus 367 degrees Fahrenheit. Pretty cold. Again, like the others, it doesn't have a surface that we could actually stand on. All these gas giant planets have no surface as such. They just get denser and denser as you go down into the planet. The gravity is only 1.2 times that of the Earth. The winds are tremendous. It has the highest winds that we know of in our solar system, 1,200 miles per hour. It also has a large dark spot. It actually has a number of spots which apparently are giant storms, but they don't last nearly as long as the ones that we see on Jupiter. And interestingly, like Jupiter and Saturn and Uranus, it actually radiates much more heat than it receives from the sun. So it has internal heat which is radiating out, and it's cooling down all the time. Neptune is essentially a twin of Uranus. Why is it a twin? Well, first of all, you can see the diameters are almost identical. 30,700 for Neptune versus 31,690 for Uranus. So pretty close to the same. It has a core of rock and ice and an atmosphere, very thick atmosphere of hydrogen, just like Uranus. In fact, the atmosphere is 85% hydrogen, 13% helium, and also has water, methane, ammonia, and other such. Now this axis is inclined only 1.7 degrees, so not nearly that extreme 97 degrees that we saw on Uranus. And it does have some very faint rings. All the outer planets have rings. Not only Saturn, but Jupiter, Uranus, and Neptune all have rings, but they're very faint compared to the rings that we see around Saturn. Now, Neptune's year is quite long now. We're talking about 165 Earth years just to make one circuit around the Sun. It's traveling now at only 10,800. That's now 10% of the speed that Mercury was zipping around. So being this far out, you don't need much speed to remain in orbit. The axis of rotation, a day essentially on Neptune was only 19.1 hours. It has 13 known moons. It may have more than that, but we know of 13. And it's now 2.8 billion miles from the Sun, or 30 times the distance of the Earth from the Sun. Now let's talk about Pluto. Pluto in the last few years has gained a lot of notoriety because the International Astronomical Union decided that Pluto was no longer a full-fledged planet, but was called a minor planet, or planetoid. Why did they do that? Well, we'll explain in just a minute why. You can see it has quite an interesting orbit. It's highly elliptical, for one thing. And now the speed is down, interestingly, about the same as Neptune. Why? Because actually it shares the orbit with Neptune. It actually crosses inside Neptune sometimes. So its closest distance to the Sun is 2.7 billion. Remember, we said Neptune was 2.8 billion, but it stays pretty much at 2.8 billion, whereas Pluto has a tremendous elliptical orbit and swings in close to the Sun. When it's close to the Sun, it actually has an atmosphere, and that atmosphere freezes out as nitrogen ice onto the surface of the planet when it's farther out. So it has a rotation just same as the other planets, and it has 3 moons that we know about. Now, Pluto would make a very good comet if it was sent to the inner part of the solar system. Why? Because it's mostly water ice on the outside, as far as we know. As I said, we're sending this New Horizons probe out there, and it's the fastest probe we've ever sent anywhere, and yet it's still taking 9 years to reach Pluto. That's how big our solar system is. So the International Astronomical Union had a tough time deciding whether or not Pluto ought to be included. And so finally said, let's define a planet as something that's spherical, something that orbits the Sun, and finally something that's large enough to clear the area around it of other bodies of similar size. And that's where Pluto fails the test. It simply does not do that. As you'll see, there are many other bodies out there in the Kuiper Belt, and these are just some that we've discovered. Urus here is actually larger than Pluto, and there are many others out there that are about the same size as Pluto. So we can't have 9 planets. We can have 8 planets, or we can have dozens and dozens of planets. I would rather have to memorize only 8 rather than 3 or 4 dozen planets. So Pluto and the asteroids, many of the big asteroids and these others, are called planetoids. And they, I think, deserve it. You notice that Pluto has a rather large moon here, plus 2 very tiny moons. So we'll be getting a close-up view of that planet when the New Horizons probe finally reaches there in 2015. Now, so I said the trouble with Pluto is, first of all, that it's really a member of the Kuiper Belt. It's a planetoid within the Kuiper Belt, and it's one of probably hundreds of other objects of the similar size that's out there. And to me, one of the most important things, we have 5 moons within our solar system that are larger than Pluto. So it deserves, as far as I'm concerned, the title of planetoid, or minor planet. Now, this completes our tour of the solar system, a very brief tour. The next program is on nebulae and star clusters. This is a very beautiful presentation. I have many beautiful pictures of these nebulae, and they're absolutely gorgeous, and you'll really enjoy this talk. So I hope you'll join us for that program coming up next week. Now, I want to again encourage you to try to attend a meeting of one of these astronomy organizations, or Star Party, for instance. The Vermont Astronomical Society puts on star parties almost every weekend in Burlington. So you can find out about those, as well as find out about their meetings at vtastro.org. The SOVERA, the Southern Vermont Astronomy Group, also is putting on a large number of star parties and meetings, and you can see them at solvera.org. And again, if you want to talk to me or ask me any specific questions about astronomy, you can reach me at astromanvt@gmavt.net. Thank you. We'll see you soon.